Alright, so I had a bit of a look around. I actually realised that the inner that we had before was the same as the one that I had ages ago, right? The one that I was sent. I don't mean code-wise, I mean the steps that it took. And what that actually showed is that it was meant to prioritise running like abstractions and stuff first, whereas outer, I think, is meant to prioritise running macros first. Now this is not something I'm 100% sure of, because I think there are situations in when it's not always going to do a macro just because there is one. However, at least for this example, as you can see here, that is how it works. So what I did, actually, I just swapped these two lines around. You see here we have, what is it? We do the inner red n1 dash, and then the sub macros, whereas here we do sub macros first, and then inner red n1 dash. Yeah, as you can see, this is 3 steps. 1, 2, 3, and we're down to Lambda 3 already. So that works. And I kind of dry run it in my head a bit, ish, and I'm pretty certain it would work. Obviously I haven't changed inner, we know that works. Pretty sure it would work for all the other cases that I've got. What I am going to do though is just check one of them. So let's just do that then. We just pass it this one, remember from before, which is exactly the same, but we have actual first in this. Right, so this should take 4 steps.
Why upgrade to YouTube Premium?
It shouldn't take 3 now, just because I've changed that. That is the aim. So let's see. That's 1. That's 2. That's 3. And that's 4. So it actually works. So yeah, with these 2 examples we've got anyway, with these 2 here, it works. We get 4, 4, 4, 3. That is what we get. Now, I suppose we should try this one. What you have to notice as well is that this gives nothing and this gives 4. It's not that it's taking a long time, it's just that this one breaks. So I'm wondering, if I look at this, if it's going to be one of those delete definitions things. And I really hope it is. So let's see, this is inner that doesn't work. Inner is going to extract second first. Then it's going to pass this into second. Yeah, I guess. Oh no, second. Oh, look, it's got the extra brackets around this, look. So it's going to just return ID. And then you've just got ID that you extract, and then, yeah, I don't know why this doesn't work. Whereas with outer, it should do ID first. Ah, no, I see, look. Oh no, I see, because look, you can apply this to this. So inner is just going to keep applying this to this and never get anywhere. Whereas outer is going to go, yeah, sure, I'll just expand these. And it does what I said. But it doesn't do quite what I said, because I said it'd do second first, and it wouldn't. It would do ID first, then second, and then it would just take ID, and then it would be done. Whereas this is going to keep going forever. So, let's try it. Let's try it. We'll get our pass macro up again. It's going to need... yeah, hopefully. Boop. Okay. And what it also is going to need is this this, this. I know it looks rubbish. I'm hoping it works anyway. No, of course it doesn't. What's the problem? Yeah, okay. I mean, yeah, sure. I guess, sure. Just put them all in the wrong place, why don't you? What the hell do you call this? Huh? Okay, now this is just stupid now, isn't it? What I'm gonna do is I'm gonna do that so it at least works. And then I can replace it like this. I mean, so it doesn't error and then... Whatever, this is just gonna work, right? There we go. So this is what we've got. So let's try outer first. 1. 2. 3. Oh, that's a lot smaller. 4. And then this is done, isn't it? This is going to come up with nothing. Right? Yeah! It took 4 steps. As it was meant to. Okay, now let's try inner. 1. If he gets to like 6, I'll just assume it's going forever. 2. Oh no, it's totally not. Yeah. 3, and then 4 is gonna substitute that in. So yeah, doesn't work. I figured. But actually outer did, which worries me, because I thought it was inner that I had to work. Yeah. So what did it do here? What I'm gonna do is I'm gonna take this and pretty print it. Oh no, that's not right. Okay. I'm gonna take this and pretty print it. And then we're gonna take the result that it gave and pretty print that. And we can see exactly what went down. I pretty... Yeah, okay. Sure. Sure, why not? Pretty print. There we go. And then before I look at that, I'm just going to grab this. Pretty print that as well. So, this is what we had here. And what did it do? It expanded second. Why would it expand second? Let me see. Yeah, it's meant to do inner red N1 first. Okay, well let's see what it does. Inner red N1 tick. We're passing it the macros, and then this. It doesn't give anything for that. It totally should though, because we can expand this. Yeah, it totally should. So let's see, why not? So what case have we got? We've got a lam app, right? Lam app, which contains... what I'm going to do actually is I'm going to copy and paste this into Notepad so we can use the fancy bracket thing. Let's just shove it here for now. So this is our lam app. It's containing this lam app and the macro ID. What? Really? Let's see. So it's this applied to ID. Is that correct? I guess so. Yeah, I guess that's right. Okay, sure. So we have a lamap, right, which is containing a lamap and a lam macro. So a lamap containing a lamap and a lam macro. That's this one. And it's possible expression. There's possible expression. Wait, what the hell is this? What? Have I done something weird? Just seriously, where the hell has possible expression come from? Oh yeah, of course, it's under here. Yeah, okay, fair. Possible expression is... Aha. Aha. Lam macro. Okay. So we should be running possible expression on. Oh no, this is inner redend one. Okay, sure. Inner redend one tick macros expression 1. Right? Yes. And macros expression 1 is this. I forgot the space. Okay. Oh yeah, because we forgot to give it macros. Okay, yeah, fair.
Why upgrade to YouTube Premium? It's ad-free, so you'll never have to stop your how-tos to skip an ad. It has background play, so whether you're working out to music or listening to a podcast,
so that gives nothing as well.
Playing if you lock your screen.
Okay.
And it has mobile downloads, so you can keep learning.
I mean, you can come look if you like. It just, you know, it gave nothing. You have a lamap, the lam macro, and a lamap in it, right? Yeah. Okay. So we go back to our cases again. We have lamap and then lam mac. No, the other way around. Lam macro. Yeah, lam macro. Ah, here we go. Lam macro and expression 2. So you're saying if there's a lam macro first, it doesn't matter what expression 2 is. That doesn't make much sense, computer. Or rather me. Possible expression. Yeah, because you know that expression 1 is a lam macro, and because of the way that this works, this is going to be just empty. I think the point is this needs to be a 2. Look, we've even got the 2 here. If possible expression is more than 0, then return... Oh no. No, that's not true. Yeah, we don't know what this could be. This could be like a lamap. But this, because it's a macro, is nothing interesting, basically. So, yeah, so we should do this. But then the point is we need to rewrite this. So this is like that, I believe. Yeah, I think that was just wrong. And then what about if you've got like a lamvar and then a lamap? What's it do here? You see, then it does the right thing. The lam macro expression 2 should be the same as this. Is this returning the bool? No. Oh yeah, it just returns empty otherwise, doesn't it? Ah, yeah, but it checks here, doesn't it? Because what I'm thinking is that lamvar and lam macro should be the same. We don't need to check all of these. If it's a lamvar and a lamvar, we haven't even got a case. Do we? No. What if you're just applying two lamvars to each other? Oh, it's up here. Why is it up there? Surely this should be here then. And I guess I might as well take this and put it with it. We've got lamvar lamvar, which is returning empty. The point is, if you've got a lamvar at the start, you see, this is the thing, I don't think it actually matters what these two are. You're just meant to expand down the tree, because look, this is all the same. And yeah, if you've got like two lam apps, then I think this whole thing is unnecessary, you know? I think we take the lam app one. Now watch this, right? I'm going to save it, like this, and then what I'm going to do, I'm just going to do this, right? We're just going to say this is the case, it just does this in every case, and then I'm going to comment out the other ones for now. Wait, not that one. That's a lam apps one. All the lam app ones. There's still a few more. There we go. Because I think it could just do this every time. I think that would still work fine. It compiles. Let's go see what it does. Where's the original thing here? Try running that, see what that does. What if I pretty print these two then? So that is the correct thing. And this is not. But it is the same thing, mind. It is the same thing. Which is good at least. It's not actually worse. Right, so because yeah, like if this is a lam macro, that you don't need to check this, it's just going to return nothing, and then you know, it's fine. Actually, that's a bad example because it was checking everything there anyway. But like here, you know, like it can run this. It's just this is going to return empty, and then it'll not accept this, and you know, it's fine. I'm pretty sure this is fine. What I am going to be doing, just to be 100% sure, because if I have made a mistake with one of these, then it is going to cause big problems. So what I'm going to do is I'm going to run that test that's a different length. On inner and on outer. And if we still get the same lengths, I'm going to assume it's working fine. So here we go, we have this. Let's do inner first. 1. 2. Aha! I have found the problem. So apparently something about this is not working. I do wonder why not, though. So we passed it this. What did it do first? Got rid of the ID one? Yeah. That's correct, right? When do we pass it? Oh no, did I pass it the wrong one? Yeah, I passed it the wrong one. Oops. Oh no, I didn't. Oh no, never mind. Oh! Okay, yeah, no, sorry, I'm just getting myself confused. And so I passed it with the right one. So we ran it on that. What did it do? It first got rid of first. That's not right. Why would you do that? I mean, but why would you do that? Inner? Yeah, why would you do that? Hmm? Okay. So, inner red n1 tick of this and this. What? Really? Okay. Nothing, apparently. Which is not true because we have this and we're doing inner. So... I assume the problem is this. Let me try. Space. Okay. Oh yeah, because no macros. No, fair. We'll give it its macro that isn't helping it in this situation anyway. Yeah, so this is apparently not coming up with anything. We've got a lam abs, Lambda. No, I see the point. Because you can't just do this and this, because if it's a lam abs in one of them, then you have to actually do something. If the lam abs is at the start, you have to do the substitution. Yes, because if you look back over here, not all of these are in this form. All of these are, but look, we have the substitute. So what I'm going to do is I'm going to remove that one and then leave all the others. Alright. Let's try again. So where is it? Here we go. This. Alright, 1 step. Two steps. Three steps. 4 steps. Fantastic. And then we can do the same with outer. One step. 2 steps. 3 steps. Perfect. So I believe that is in fact correct. We just need this one, and then all of these others are just encompassed in this general case here, which I was just using for lamap and lamap, and I believe lamap and lam macro is the same, but then all the others I'd randomly shortened them. And yes, okay, technically it's then executing less code when we have this, but actually look at how much code is commented out right now. We don't need any of it. So, yeah. This is why I'm now getting worried. We also don't need this now, I believe. Wait, do we? Oh, I guess we should just test this now, right? Not sure, really. Screw you, we'll come back to it. Yeah, okay. Oh, I got rid of the macro one as well, didn't I? Oops, didn't mean to do that. It's gone now, we don't care. We don't need it. We don't need the macro one. Doesn't matter if the list comprehension was good. We don't need it. To be fair, I don't think we do, because we have our sub-macros and all. I could just turn this into sub-macro, actually, couldn't I? Sub-macro and sub-macros. That'd just be a bit nicer, really, wouldn't it? Why not? I mean, you know, it fits the pattern. Plus shorter, especially on this line where it's written 4 times. Oh no, 3 times. Oh yeah, 4. Yeah. Yeah. This is a bit shorter, you know, this is a bit nicer. Oh yeah, we will have to do that though, to be fair. Yeah, we'll have to do that. Okay, yeah. I think that's good. So then, what we have now, finally, we can get back to the example we were trying to do earlier. Which is, mind you, that thing that I just deleted, but I was thinking we would just remake it to be sure it's all good. So I'm just typing it back out again in the parse_lam macro. No, I just want to make sure we've got the whole thing. I don't accidentally copy and paste half of it or something. So here we go, we have this again. Right. So, inner red n1 of this. Right. Now let's check if these two things are the same. Here is the output that we just got. They look exactly the same to me. Fantastic. So inner red n1 is now looping on that, which sounds like it shouldn't be a thing that it's doing, but it is a thing that it should be doing, so that's fine. However, outer red n1 should be not. So let's count steps. We've got 1 step, 2 steps. Oh yeah, it's going down. It's perfect. I'll take it all the way just to be sure, but yeah, it's good. What? Why did I have to say that? I copy-paste it wrong. Yeah, I did, okay. So what's that, 3 steps now, right? Oh, for goodness sake, what am I doing wrong? I think I'm just being retarded or something. There we go, 4 steps. And yeah, that's all done now. Lambda, and that's correct. So, in other words, it works, which is fantastic. Innermost and outermost. In that case, we really cannot any longer call this inner red n1, can we? I'm thinking, most of all, it at least does both. Even though we initially did not intend it to, because for some reason just swapping these 2 lines of code around and reversing this is all you need to do to make the difference. I have no idea how this is working, to be honest. But fantastic. Let's go. Big thumbs up for that. In which case, let's get to renaming, right? Now, give me a sec. Ah, yes. I have me the gacha rolls. Which is all well and good and fun. So just give me a sec. Okay, that will do for now. Now what I need to do, is find a val BCN or whatever it was called. Shall we just call it reduction or something? That'll work, right? I have no idea what to call it. If nothing else, it needs to make sense to me, so sure, it can be that. Now, is that all of them with the tick? I think so. So now we just need to do it in here as well. This is now called reduction. It's not inner anything. Here's the other ones. This should be all of them now. So this is now actually a reduction. Hopefully that's correct. And then all we need to do now is this, which is going to be really fun. Yeah. To be fair though, this should not be too hard. So if I have a peek at the instructions, it's basically just evaluating each one until it's finished. We also need to be doing it for the CPS transformation. CPS? CPS? Yeah, CPS. Which we've already coded up in challenge 5. That one was not too bad at all, mind. Not too bad at all indeed. So the main thing that I need to be doing here is checking how many reductions it can perform before it returns a nothing. Or one, not even a nothing, an empty. Oh yeah, no, a nothing, a nothing. Yeah. Before it returns a nothing, right? Yeah. Okay. Which should not be too hard to measure either, to be fair. So we've got our Lambda macro expression. Both of these just get passed in an expression now, so we'll call this lam expression, sure. And an integer, oh yeah, this is the bound. Oh yeah, because we need a bound. Okay, yeah, sure. So I think we should write 4 extra functions for this just to make it a bit easier. I don't think it'd be necessary. I think we can just write it all in here. We could maybe do it with a where. That could work, but I'm going to do it with 4 separate functions just because I think that'll be a bit nicer. So first we'll do inner reduction. Why is there even an N on this, to be honest? Inner reduction. We'll just call it inner red. Sure, why not? So it's taking this with a spacebar and it's returning an integer. Right? A maybe integer. Wait, why is it a maybe integer? Ah, because of the bound. So it needs to take an integer as a bound as well. And then it can return a maybe int. Okay. We could actually make this one function, couldn't we? For all 4, I mean. And we could just pass it what type of reduction that we want, and then... Maybe? That seems quite smart. Pass it like a string. Inner or outer. I don't know, it's fine. I think we'll just leave it. It'll be simpler like this. We'll just copy and paste the function underneath and it's fine. So what we need to do is we need to call inner redn1. Oh yeah. We've got our lamb expression and our bound. Right. Oh, so base case actually is when... Ooh, that's smart, that's smart. We can have base case is when bound is 0. Right, we don't need another line for this, let's just have a guard. When bound is 0... Okay, now hang on. Are we actually returning nothing? So, if we've hit the bound, then... yeah, then return nothing. Okay. If you've not hit the bound... oh dear. Maybe we should do an original bound and then the recursive bound as separate arguments. That might work. So go with me on this. We can have OG bound and then actual bound, right? So then what we're actually returning is OG bound minus bound. Adjust. This needs to be an adjust. That's basically the case, right? I believe so. Let me just think about that. So, if you give it, say, bound of 10, then it recurses and reduces the bound by 1, relieves the OG bound, it leaves the OG bound as 10, and then you would do, so you would have 9 left, and you would take one away, and you would say it's been 1 step, right? So that works. Okay. So what we have here is rather than otherwise, what we just put is if inner redn1 is nothing, right? So if we put it through inner redn1 and it gives nothing, yeah? And then we have our otherwise here. Return just of, yeah, but then return of this is a maybe as well. Okay, for now let's not have this as a maybe then. Now this is 0. This can be inner redn of inner redn1 lamb expression. OG bound stays the same. And then we have bound minus 1. Right, because then each recursion it removes 1 of the bound. Yeah? Does that make sense? Who knows? Let's test it. Does it even compile? No, of course not. Data constructor OG bound. Because it starts with a capital letter. Screw you. What are you gonna do about that one, huh? Stupid Haskell. Oh, it still doesn't work. What? Ah, because this is returning a maybe. That might work, actually. That might work. Legitimately, though, that might work. You just have to pass it as a just value. Oh, this is going to be so cursed, I'll tell you that. But that might work. Okay, let me see if it compiles. And then I'll peep you guys over to the CMD. No, it does not. It's still complaining about the maybe. What's wrong with the maybe, huh? Now, hang on then. Where is this anyway? So this is the same line. Did I not save it? Ah, that'll be why. Okay. Oh no, but... No, never mind, that didn't help. Why were you expecting a... Ah... Okay. I know what we can do then. So we just have this case first. This is where it gets past nothing. Then we have this. We remove this line. We put a just here. Wait, that's not the brackets in the right place. Okay, let me try this then. Oh, yeah, that compiles, that compiles. Okay. In a red. Oh wait, what am I even trying to pass it? Let's pass it one of the challenges. Sure. Pass it one of the simple ones. Actually, no, let's not. Ha 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 ha. Screw you, you don't get one of the simple ones. Pass it this thing. This is obviously the favourite challenge. We like this one. So we're actually passing this with the just. And with the brackets as well. Yeah, okay. Oh, no. Oh yeah, bound. It needs to be past the bound twice as well. Let's just randomly give it a bound of 10. 5. What? No! It's correct as well. That's correct, because, think about it, if it takes one step, no, I think that makes sense. Because of the way that the cases work. I'm going to need to add an extra takeaway 1 on here. I'm just making sure that I'm not retarded. So it's going to do the yeah, see, this is the thing. This counts as the 5th step, this check. it's already done the -1. So it's already taken 1 off the bound, and that adds to a +1 here. So you are going to need to have a take 1 on the end. Yeah, okay. 4. It said 4. I know you can't see it, it said 4. Perfect. Perfect. So then... when does it return nothing? When it hits the bound. Right. If bound equals 0, return 0. Ah, yes, see, this is the problem. This is the problem. Because it could take 0 steps. That's not the same. Well, actually, this is easy. We just do this, right? We just do this. And then here... should we have inner red tick? Where it... That makes a lot of sense, actually, yeah. Inner red tick. Which doesn't need the maybe. Only needs one thing here. And actually returns it with the maybe. It's going to take lamb expression and bound. And it's going to run in a red... actually, we should do these ticks the other way around. We should do it like that. That makes more sense. It's going to run in a red tick on just lamb expression. Bound. Right? Because this is why we're doing this, because it does this silliness. But then what we need... we need a guard. So if this is less than 0, return nothing. Otherwise, just return whatever the hell this is. Right? Okay, let's try this. No. Why not? Is it because I'm stupid again? Yeah, it is. I thought it was. Beautiful. What now? Yeah, this should be adjusted. Okay. Still not correct. Goodness sake. Where? What? First argument of inner... Oh, yeah, I just forgot the tick, don't mind me. Okay, there we go, that works. Come over and have a peek. I am now going to pass it a bunch of random tests. So first, let's pass it the one that we did before. Oh, let's not. No, that's fair, it's because we don't need that. We don't need the extra adjust either. Because I made it sensible. Well, more sensible anyway. There we go. Just 4. Oh, perfect. Now let's do a couple of the others. So, for example, let's do this one. Boop. This one should be 0. Okay. Bound. Bound 10. Just 0. Okay. Then let's try this one. This one should be 1. Oh, wait, we need to pass it first. They're all written in, you know, nice words so I can read it, but computer can't, so that's fine. We just do that. inner red, bound 10. Just one. Fantastic. And then, what about this beautiful thing here, which I also hate? I don't know why that one always randomly gets replaced with a lambda and the others don't. I mean, it's because it's written with a lambda, but I don't know why it's like that. Okay. Inner red, this with the bound 100. Nothing. Oh, that's beautiful. That works. That's what it's meant to do. That's epic. Alright then. So now all we need to do is to make it do that for, you know, the others. Right, so. The only difference is this, right? Yeah, that's the only difference. What I'm thinking is doing something fancy. Instead of passing it like a string, inner or outer, what we could do is actually pass it the function here. We can call this find steps. Right. Just go with me on this. Right. And what it's going to take as part of its arguments is this. Right? Right? We'll call it method. Right? And then here, we run method, right? And then, what is it? Here, instead of running this, we run that, and we pass it that. Okay? Do you think this is going to work? What are the chances? No, it does not work. Did I save it? Yes. Did I miss one? Yes. Fair enough. Okay, what about now? No. Yeah. Oh, that compiled. Now let's run some of those that we just did. That still returns nothing. Good. This one still returns just one. Oh, that looks like it's working to me. Because here's the thing now. Oh yeah, you didn't see. Basically, it did the same output as last time. Right, that's all. Right, so now, here, instead of copying and pasting both of these functions, we only copy-paste this one. Still copying and pasting a function, you know, like whatever. But it's a bit nicer, right? We just change all these inners to outers. Right? There we go. So now here, these two just be inner red with the arguments lam expression bound this is outer, and then for these two it's exactly the same, but instead of lam expression we need to transform it. So here's our CPS transform, and it takes a lam expression anyway. There we go. You just plug that in here, like that. Now see if this is going to compile. Oh, it actually does. Okay, now we have something to do. Right. Oh, this is nice. Wait, bound? Is it passing? It's passing it bound. Oh, we're fine. We're fine. Okay. Now we can test all the values. So, let's start with the first one. Pass lam macro this. Then we take the output of that and put it. Are you actually looking? You are. Fantastic. Put that into compare inner outer with this and the bound 10. I believe it said 10. Okay, are you ready for this? 0044. Oh no, that's not correct. That's not correct, guys. It's not the one that we wanted. Oh, I cry. Let's check the others just to be sure, but basically, yeah, it doesn't work. I said it probably wouldn't, to be fair, but you know. You can hope, can't you? It's I know what it is. It's the what's it called? My reduction function. 100% it's my reduction function. It's got to be. I think you need a separate reduction function for inner and outer, not just the same reduction function, but you swapped the arguments around. Like, nah, not a chance. But yeah, let's go through and test all these. Bound 10 again. 1 1. It's meant to be 3 3. 1 1 3 3, but no. Yeah, okay. What about this one? Compare inner, outer with that and the bound 10. 1166. Meant to be 1188. Oh no. Oh no. You know what, it could technically be my CPS transform that's causing the problems, but it won't be. It won't be. I've just built my reduction thing around the examples that we've got without the CPS transform, so of course that's going to be the case. Right, next one. This is this silly infinite one. Ah. No, it's just because you missed the space, you silly. Whoa, what was that? How? What? How? Whoa. That doesn't make any sense. I don't know what I was doing. I was right clicking. It was doing something funny, cool stuff. Compare inner, outer. That and the bound 100, right? You said 100? Yeah, bound 100. Oh, that one works at least. Now this one. Passline macro. This. Again, we've got to go through and do. No, not there, you silly. Do them. Okay. Compare inner, outer with the bound 30. 4 4 2020. It was meant to be 22 22, but yeah, alright. It's close! Look, it's close! It's almost there. Nearly. It's too fast. I mean, what can I say? It's just too fast. Is it actually too fast on all of them? It's too fast on all of them. My algorithm is just too damn good. Oh. To be fair, I don't know why they would enforce it being slower. Like, I mean, you know, if I've written a faster algorithm, give me a prize, you know? Oh dear. Maybe I can get away with just adding a couple on randomly at the end of every expression. The next one with also bound 30. 4, 3, 19, 19. It was meant to be 21, 21. Honestly, are they all 2 off? This is 6, 6, meant to be 8, 8. These are... It actually is, it's 2 off every time. This is a pattern. Maybe this is actually easily fixable. Maybe. Maybe. Let's do this last one. Ah, slam macro. That. Oh yeah, this silly one. The long one where we have to enter it multiple times because it's silly. Okay, there we go. And then compare inner outer with this and the bound 1000. That's correct. So it's just too high on everything. I'm gonna complain about this on Discord. Let me see. Somehow I get these values. All the CPS ones, CSP. Wait, it's CSP, isn't it? Have I been reading it wrong the whole time? No, it is CPS, okay. Every time I question it. I question what it's meant to be. Yeah, I'm just too fast. I'm just too fast. So, what I'm gonna do is I'm gonna print one of them out. So let's do the easy one. This one's only meant to take 3 steps, and I'm just doing it in 1 step. It'll be further up, but I don't know which one it is, so let me just reprint it. It won't exactly take long. Here we go, we have this. So let's say we just print this, you know, bound 10, we get 1, right? So it's meant to take 3. Huh, how could this possibly be a thing? What I'm going to do is I'm just going to skip ahead a few steps. I'm just going to shove it in reduction. So that doesn't work because of this. Yeah, so that's correct. On inner, it should be doing... Wait, hold on. How the hell is this only... That should be 3 steps. Oh, I didn't transform it. That's why I'm getting so confused. Right, okay. What's the function called? CPS transform, I know, but shut up. Caps and such. Right. CPS transform on that. So mine apparently does this in 1 step. Well, yeah, why wouldn't it? Huh? Okay, so let's see. So inner red N1. Yeah, we substitute this in, right? And then if you do inner red and 1 again, on this, you get nothing. Yeah, I mean, at least that's what I expected. I assume there is some reduction to be made here. So let's take a closer look. Just give me a sec. We have more of ligature rolls, which we do enjoy. In fact, I already missed one, so screw you guys. Another 8 key on Uchiko Raraka though, so you can be happy about that. I also messed up completely and threw away an orange Kakura, so that's fun. And then here, yeah, nothing particularly interesting. I would let you guys come have a look, but like, there's really no point. It's not exactly going to take long, is it? In fact, we're done. So fantastic. Got Gary Karma's great waifu, I know. So what I'm going to do is I'm going to print this out, pretty print. Apparently there's more reductions to be made here. What flavour reductions would that be? No brackets at all. Okay. Wait, hang on, we might have some updated information here. Do you do this to the CPS transformation? Yes, reduction in CPS to the identity. Innermost reduction on the CPS translation of E applied to the identity.
You're into
Hold
something
up.
new, and you want to get good at it. Like, really good at it.
What is this?
Premium can help
Let me go look at the instructions.
You can study back to back to back.
Wait, you know what?
ads.
Shut up, YouTube.
Download video.
Are we on? It keeps putting me off shuffle, though. Whatever. Back on shuffle again now. This is why I've been getting so much chime. Okay, I'm going to ask him for an example. So, yeah, what have we got here? x2 to x2. X1 to... What? Extends all the way to the right, right? So what, this is an application, right? Maybe I should just read this one. Damn. Absolutely. You're applying var2 to that. Hang on a sec, I'm just asking for this example. They said no. Yeah, so we've got the application, right? But you're only applying... Yeah, actually I kind of see it. So you couldn't do anything with this. or with this. But you've got x2 to that. Oh yeah, but you haven't actually been given any arguments to it. There's no application here. The only application is... Oh, yeah, this is an application. Oh yeah, but this is a variable. So you're applying this to this. But yeah, so I see no reduction. So, it is probably my CPS. Which is what this guy says on Discord as well. He says, maybe I don't do something to my CPS transformation. Innermost reduction on CPS translation of E applied to the identity. Why am I applying E to the identity? In which situation am I applying E to the identity? What? Apparently I need to apply E to the identity, guys. Where? Oh, what? Where? When? How? V. Yeah, I'm trying to find this in the instructions here. This bit here, right? So this is for challenge 5, right? This is the CPS transformation, which we did, and this is the thing, it passes all of these. Wait, hang on, no, this is... Isn't it... Wait, no, but this is that anyway. Look, this one here is the same as this one here. Right? I'm not going crazy. It's the same. So you should be getting this. We substitute this in for F. And then you end up with this. And this is what we've got, right? x2 to x2, x1, x3 to x3, and x1. Yeah. Yeah. So what's the wrong thing? What's up? Yeah, my thing looks the same as his. I've just got variables called different things. CPS transformation. Wait, is this something in here then? Innermost reduction on CPS translation of E applied to the identity. Oh, wait! Is this? This is what he's on about. What are we applying? Of E applied to the identity. Ah! Ah! I don't know why, but yes, I think that's what we're missing. So what we need is here, instead of just doing CPS transform, we need some extra brackets. And then this randomly is a llama. No, but this is a macro expression. Wait, no, hold on, this is a macro expression. E. Ah, no, so it's not the whole thing. It's not the whole thing. Wait, but no, but E is also... E. Wait, what's E? Hang on. What's E in this case? Outermost reduction on E. This is E. But E is got macros in it. So I'm thinking maybe what you're doing is you're applying this bit to the identity, the expression, right? Or this bit to the identity, or this bit, you know? And not this bit? That would kind of make sense. That wasn't me. I didn't sneeze. Why would I sneeze? I have no reason for sneezing. Yes, I think probably it's the expression applied to the identity, but it's something that I kind of want to check. On the other hand, I can always just do that and then check if it adds an extra 2 on, which probably it will, to be fair. But I'm just seeing what these people are saying about it on the Discord. What I might do is have a chat to these people about it.
You're ready to relax and find peace, but your calm meditation guide stops when the screen locks. Get YouTube Premium.
Yeah. I'm gonna
and offline play so you can
go away for a minute and see if I can figure out what is up with this and have a chat to these people, and I'll come back when I know what I'm actually applying the identity to. Alright, so turns out the instructions are pretty ambiguous. What it says here, innermost reduction on CPS translation of E applied to the identity. It could be the CPS translation of E applied to the identity, or it could be the CPS translation of E applied to the identity, depending on where the comma is, here or here, and that makes such a big difference. Obviously, I'm complaining because I read it the wrong way around, and that's why I was so confused earlier. But we have it now. So what I've done is I've made this extra function transform for comparison, which basically takes a Lambda macro expression and in the expression part of it, it adds the lamap with this. I was trying to do this with a where, but for some reason it was infinitely looping. I have no idea how it even managed that on a single expression. It wasn't recursive or anything, it was just a where. Yeah, I had this where, and then I had another where underneath, but I changed it so it does this instead, and that works fine. And the best news of all is that we get these results. The other thing that I've noticed, I knew they were there, but they used to be broken. This is the thing, because here's the examples all written out nicely, but they all use XID for some reason, which is kind of annoying, because XID was defined incorrectly. And back when I first got this file, I didn't know that because I didn't understand what the hell any of this was. So I didn't fix it. Now, of course, I kind of get it, so I fixed it. And XID now works. So we can come over here, and as you can see, we've got 1, 10, and it gives 6, which is correct. 0, 0, 6. So now we do the same. XID 2, 1, 1, 3, 3. Then the next one should give 1, 1, 8, 8. Yeah. Then this one is with bound 100, so it's nothing. Then the next one is with bound 30 and gives that. The next one is also 30, gives that. And then the next one is, I'm doing this all in the wrong order. It's bound 1000 and gives nothing. Well, it gives that 1, 4. So yeah, basically correct. So that's good. The most magical bit of all of this, obviously, is still the fact that reduction works. I have no idea why reduction works for inner and outer. I still feel like it probably shouldn't. I feel like I would need an inner reduction and an outer reduction, because my inner and outer reductions at the moment, I mean, you can see it's literally just copy-pasted the same code. These two are the other way around, and this one has a reverse. In fact, I don't even have the reverse over here anymore. It's literally just this one reverse. That one reverse, and then these two lines are the other way around. And that is the entire difference between inner red N1 and outer red N1. So I feel like that's not correct, but sure. We've got our find steps, which again obviously is the same for each. It just shoves the method in here. We pass it the method here, which is nice. I did like the fact that that worked. That was very nice. This I was pleased with that. That was good. And then yeah, we've got our new little function down here and the compare inner outer. All in all, it does exactly what it was meant to do, which is fantastic. As far as I'm aware, obviously, as far as I'm aware, I have periodically been going back and discovering mistakes in the older ones. I haven't recorded all these little changes, but yeah, there've been little changes all around the place. The last one I did, I believe, was all the way back in challenge 3. I'll just show you this one, just to give a little demonstration. Where was it? In the print macros. So this used to be just empty, but what I discovered is that it is actually meant to be doing the substituting macros in. If you have a macro inside another macro, then it's meant to substitute it still, which is magical in my opinion, but sure, we'll go with that. So instead of just passing it an empty list of macros, this time it now passes it to the actual macros list that it gets. Now the problem with that is obviously that then it'll just go f, that's defined as the thing that I'm trying to print, that's the word. F is defined as the thing I'm trying to print. I'll just write f, and then it'll say f is defined as f equals f, and it's just wrong. So then what I needed to do is define this little function here that removes one of the macros from the lists. So yeah, there we go. But it was just a small change. I mean, this must have taken me 5 minutes to do. It's not hard. And that just fixed that one. And yeah, it's just little things like this where I discover the functionality is slightly different from what I originally assumed, and I go back and fix it. There may be more of them. but I don't know about them. So for now we're all done. Lastly, we're going to have to do the testing file, which is going to be great fun. And like I said, I'll put that into a separate video. We also have a report to do, so yeah. It's all going to be good. But for now we're all done. Everything is finished. Wonderful. In terms of code. Commenting and testing next. That'll be next video coming out tomorrow. Alright, bye!